Okay, so generalizability refers to the appropriateness of applying findings from a study to a larger population. Generalizability requires random selection. If the participants in a study are randomly selected from a larger population, it is appropriate to generalize study results to the larger population. If not, it is not appropriate to generalize. Observational studies do not feature random selection, so generalizing from the results of an observational study to a larger population can be a problem. Only when you have your actual experiment and you've conducted it with randomization, or unless you trust that they have randomization in there, can you actually do something like this. This is a problem a lot of people have these days, in that they just go ahead and just take any study whatsoever and apply it to everything. Once again, I'm going to harp on it. It's the autism study. That study was very much so not done. That was actually a specialized sample that was it was too small to actually apply to the general population of people. Okay, so that was an actual pitfall of that one. Anytime you notice something that has just a smaller sample size, that's a huge issue. So anytime small sample sizes are happening, small sample size, that's a huge issue. Okay, sponsorships. In other words, if when you're looking at the actual study, it's being sponsored by someone and it's not a credible a journal by an independent scientist, then you have some issues. You have confliction of interest. If there's no blocking in the experiment, that's a huge issue. If the person can't replicate it, that's a huge issue for generalization ability. So no blocking, not being able to replicate the information, no stratification. Okay, that's a huge issue right there. All right, and too small of a sample size. Once again, those are just the huge parts that just deal with generalizability, that you can actually generalize to the actual public or the larger population in whole. So in other words, if I was doing if I created my own experiment, but I only used the 9th graders, and not like saying, like for example, you know, how many of you guys ride the bus home, I would get a huge or a much larger response. And then if I said, oh, this school has, you know, for example, the entire school it rides the bus 100% of the time, which just means we don't need the parking lots. Well, that would be unfair because I only asked the freshmen who can't drive, and that would leave out the juniors, the seniors, the sophomores, some of them that can drive, and also the staff and, like, you know, the teachers, the principals, and the school support staff. So those are huge issues when bringing up this stuff. So generalizability actually affects everyone, because a lot of people forget to account for these confounding variables, not confounding variables, but these attributes that just they don't pay attention to in statistics. And this is why in statistics everyone needs to know it, is you need to be careful about all of this. Okay, and that's it for generalizability. I'll talk to you guys later. Bye.